So it was not too bad in terms of try using find, but the challenge is how do we store the result and how we even use the result. Well, we say that iterator is a helper to connect different parts of our program, for example, those algorithms, with our containers. So before we proceed to this place and finalize it, let me do another demo like this. Instead of just going directly to find, I can do this. I would like to capture this iterator before using this find. And so I can say standard vector, a standard string, and then so this is the type of my vector. It's really a vector of strings, but because everything that comes from the standard library needs to be prefixed by the standard library namespace name, which is std. All right, I can somewhat simplify this notation if I did this. If I said I am actually using std vector, right, and I'm also using std string, right? I could say it at the top of my program, or I can say it anywhere I want, and the compiler should basically understand that then if I simplify this syntax, okay, if I want to simplify this syntax, then I can do something like this to make it easier for us to work with this initial arrangement. So vector of strings. So now I got rid of standard library namespace in front of those guys, okay, by saying, okay, that's what I'm using. All right, so I would like to produce an iterator because the documentation tells me that that function begin defined by, this is the instance of my vector of strings, right? So if you call begin, it will return an iterator. Well, let's just kind of make it look like it. It's a popular name for iterator, it. But who knows what type of object this is? The answer to this question is that the vector knows what this type of object is. It's the vector defines it defines itself, but it also provides the type inside vector that defines an iterator. If I can just spell it, right? So there is a type supplied by the vector which can be used as a helper object, and to create an iterator and capture it, the standalone version of it, you can use this as a type, and this will give you an iterator which will be connected to our container, but also will be pointing to the beginning of our container, which of course we know, like element index 0 if we compare it with our arrays. Okay, so therefore I can also essentially use my iterator right here. So now instead of calling it on the fly, I can supply my iterator. Okay, so this would be doing the same thing. But instead of doing this, I'm not going to use this iterator right now because we should have a somewhat specific discussion about the iterators. But so instead of just saying begin, I will say, well, let me use it with find. Right? Just like this. Let me use it with find. So basically what I'm saying right now is that find should start at the beginning of my container, should stop at the ending of my container. By the way, those iterator objects are returned by this call and by this call into my container. And find should also look for hello in this range from the beginning to ending, okay? And what it returns back is an iterator. Now, but how do I really prove that what it gives me back is hello? What happens is that just like with pointers, if I wanted to have a pointer, I could say this with, let me give an example with, actually let me just get rid of this little piece here and go back to the array. So before I destroy my array, I could say integer pointer ptr equals my array, right? And I want to point to like the 56 element if I wanted to, right? 56 element, right? But this 56 element is an integer. So to have my pointer pointing to 56 integer, I need to basically say, give me an address of it, right? But then if I wanted to, all right, you know, like let me say 56 elements equals 555. Go ahead and give me an address of the 56 integer in this array of 100 integers, and then I could say something like this: cout, right? Cout output, and to be able to display it, of course, with pointers, I need to dereference the pointer. Okay. So I need to dereference the pointer. Of course, my compiler has no idea what this is, so I need to say iostream, right? Iostream, and then I also need to say, well, maybe that I'm using stdcout. Okay. Many people will put it right at the top of the file, but it can be taking place anywhere you want, right? So now, in order to get to this number 555, if I'm using a pointer and I came up with a pointer to an integer, that I was able to go to this place in my array and say, give me an address of it. So now to use a pointer, I need to dereference it, and so this should be printing 555 on screen. Well, by analogy with iterator, iterator behaves or tries to model the behavior of a pointer. Therefore, the way for me to go is this: cout, right? If I wanted to display hello, but I have an iterator helper object which points to something that's supposedly hello, I need to dereference the iterator, and this dereferencing will do exactly this. So let's compile and run this. And this whole thing should print 55 hello or 555 hello if we didn't mess it up badly. Warning on reference local variables. Yes, we never use any variables, but if we run this, so there it is, 55 hello. So pointer worked, but the iterator also worked as being dereferenced. But first, we were able to make sure that our iterator actually, let me actually dismiss this window entirely, right? First, we had to make sure that we used something that was able to search through, locate element that looks like this, and return back an iterator. So iterator is a helper object that allows us to work with our containers, in some cases very effective. Now, with vectors, however, remember that with vectors, you know, if I wanted to use it very much like in an array style, I could do just this: display, you know, display this. Because vector also allows me to have indexed access to its elements. So here, of course, no need to use iterator. Me, the user of my vector, knew exactly where this place was, so I'm telling, okay, go ahead and just give me that element. This, of course, returns back a string, and then string is being sent to cout, and cout will print hello again. But look, this example is very primitive. I knew where my hello was, right? So it's like cheating. I said, okay, go to this 56 subscript this 56 element and print what it is. But here I was looking specifically for hello. So here, you know, if I had another element populated with hello earlier on, it would of course be found first, right? So let's create a loop which searches for all hello on file. So let's say that we populate element number 10 with hello, element number 56 with hello, and element, I don't know, element 17 also equals hello. So we have three places where hello is stored in our vector, and we just, you know, by our will, we did this. So let's save this segment. And once we do this quick demo, we'll take a break.